Alright, so today we're going to learn about momentum. Momentum is equal to mass times velocity. Its units are kilograms times meters per second. So mass units times velocity units. So what letter do we use for M, or for mass? M. What letter do we use for velocity? V. And what letter do you think we'll use for momentum? That's mass. No, you can't have two letters. P. So it's for the Latin word. So YP. So the reason why we use the letter P for momentum is it comes from the Latin word pater. But you don't need to know that. All you need to know is that momentum is equal to mass times velocity. So we can make a triangle from this. Guys, quit talking. So momentum is equal to mass times velocity. You probably heard it's hard to stop things because they have momentum. So objects with large momentum tend to have more inertia. Are harder to stop, I should say. So momentum, if something has a large momentum, it's going to be hard to stop. Let me give you an example. So a baseball has a mass of 0.25 kilograms and a speed of 20 meters per second. Yes. Do you not see me circling it? We didn't invent anything like newtons. It's just kilograms, meters per second. So a boulder has a mass of 5 kilograms and a speed of 1 meter per second. So which one has more momentum, the baseball or the boulder? They'll be the same. So for the baseball, the mass is equal to 0.25 kilograms. Its speed or velocity is 20 meters per second. So the momentum is just equal to mass times velocity. So 0.25 kilograms times 20 meters per second. And we get 5 kilogram meters per second. For the boulder, its mass is 5 kilograms. Its speed is 1 meter per second. So momentum is equal to mass times velocity. So 5 kilograms times 1 meter per second. So its momentum is 5 kilograms meters per second. So two objects can have the same momentum. You can either have a small mass with a great velocity, or you can have a large mass with a slower velocity, but these two have the exact same momentum. So you can imagine it like this. Which would be harder to stop? Things that have a lot of momentum are can be hard to stop. We say that momentum is the reason why things tend to keep moving. So if you had a giant big rock falling down, a boulder falling off a cliff, and you were to go, or a car rolling down a hill, and you were to go over there and try to stop it, you're not going to be able to overcome its momentum. It's going to be very difficult to stop it. Or another example is if you roll a basketball down a hill. Well, that's going to be easier to stop. What if the basketball was shot out of a cannon? If it had a very high velocity, it'd be hard to stop. So, momentum, it's a nice simple equation. It's kind of like F equals ma. There's only 3 variables. Somewhat simple, right? Oh, let's go get longer here in a second. Alright. So there are a few things constant in the universe. Can anyone tell me something that never changes for all eternity? Well, time changes. It moves forward. Are we frozen in time? It's never ending, but I didn't say not ending. I meant constant. What is something that's constant? So, what is something that can't be created or destroyed? Have you ever heard that expression? Something cannot be created or destroyed. So, in the universe, so there are a few things in the universe that are constant. Energy cannot be created or destroyed. So the amount of energy in the entire universe is constant. No new energy is created, no new energy is destroyed. The next thing, so the technical name for momentum in this case is linear momentum. This is momentum in a straight line. So the total momentum in the universe is constant. For example, if we have, for example, two people sitting in chairs, and there is wheels on it. So two people sitting in stairs are not moving. So what's the total momentum of both of them? 0. So the total momentum is equal to 0 kilograms meters per second. Now, if they push each other, one will start flying this way and one will start flying the other way due to which law? Third law states that every action there will be equal and opposite reaction. So this person will, according to his mass, will be pushed off in this direction with some mass 1, whatever his mass is, times velocity 1. And this person will go according to their mass in this direction. Here, m1v1 plus m2v2 must add together to equal 0 because total momentum never changes. So total, and let me put linear in here, this is linear, momentum never changes. So if the total momentum was 0, after they start moving, the total momentum must also be 0. So the reason why these cancel out is this velocity would be negative, and this, because remember, what does velocity have? A direction. It's a speed plus a direction. This person's speed is in a negative direction, while this person's speed is in the positive direction. So in order to create motion, you must create motion without changing total momentum. So the total momentum in a system stays constant. You cannot add momentum, you cannot subtract momentum. There will always be a pair that will add to 0. Yes. The total momentum is 0. We might be asking to solve for the momentum of one person who might not be 0. So let's do a complicated example. Suppose a 3-kilogram block is moving to the right at 5 meters per second and hits a 2-kilogram block that is stationary. After hitting they stick together and move to the right. At what speed do they both move after collision, after hitting? So suppose a 3 kilogram block is moving to the right at 5 meters per second and hits a 2 kilogram block that is stationary. After hitting, they stick together. So that should be they. They stick together and move to the right. At what speed do they both move after hitting? Doing momentum problems is probably best to draw a picture of before and after. So before, pretty sure I did. I did too, post it, but it didn't take. It is posted, it's just glitched out. It says attendance has already been posted for the day. It says attendance has already been posted for this date. Alright, bye. Yes. Yes. Are you going to miss the lecture? You're going to miss the lecture? This is important, it's complicated. So we have a 3 kilogram block moving to the right at 5 meters per second, and it hits a stationary block that is 2 kilograms. Afterwards, they stick together and are moving to the right at some velocity v. So I said total momentum is constant. So let's calculate the total momentum. What is the momentum of this block? So momentum of this block is equal to mass times velocity. So that'd be 3 kilograms times 5 meters per second. So 15 kilogram meters per second. The momentum of this block will be equal to its mass times its velocity. So that'd be 2 kilograms. It's not moving. Stationary means its speed is 0. And so its momentum is 0 kilograms meters per second. So the total will be the sum of this. So total momentum would equal the sum of these. 15 plus 0. So 15 kilograms. So let's look over here at total momentum over here. So we have the mass. They're sticking together. So what's the total mass of this? So the total mass is 5 kilograms. And so the momentum, so the total momentum would be equal to 5 kilograms times whatever V is, times its velocity. These two things must be equal. The total momentum before has to equal the total momentum after. So I can set this up as 15 kilogram meters per second has to be equal to 5 kilograms times velocity. If it makes it any easier, you can drop units. 15 has to equal 5 times velocity. So we have this equation right here. We can put this in a triangle. If you can't do the math in your head, we have 15 is equal to 5 times velocity. We're solving for velocity, so velocity would equal 15 divided by 5, which would equal 3 meters per second. This is our answer. So, to recap, if a 3 kilogram block going 5 meters per second were to hit a 2 kilogram block not moving, and if they stick together, then their total velocity after colliding would be 3 meters per second. No. You have to do all this to solve it. Open the door, please, Nicole. The 14th. So let's do another example. Suppose a 50 kilogram person running at 10 meters per second ran and jumped into a 10 kilogram boat. How fast will him and the boat be moving after he jumps in it? So again, we can do before and after. So before, we got a 50 kilogram person moving at 10 meters per second. We can assume, because it's not mentioned, that the 10 kilogram block is stationary. Afterward, we will have the 50 kilogram person on top of the 10 kilogram boat, and it'll be moving off at some velocity. I just make it up random numbers. Actually, some fiberglass little canoes and boats weigh almost nothing. Alright, So, so we know that the total momentum on the left side, total momentum, would be equal to 50 kilograms times 10 meters per second plus 10 kilograms times 0 meters per second. So it's moving at 0. 0 times 10 cancels out, so this is just 500 kilogram meters per second. Afterward, the total momentum on the right side is equal to the sum of these. So 60 kilograms times whatever this velocity is. We know that these two must be equal. So 500 kilogram times a meter per second is equal to 60 kilogram times velocity. So we have some equation equal to the product of these. We can draw a triangle. We know 500 up here times is equal to 60 times v, circling v. Velocity is equal to 500 divided by 60. This was kilogram meter per second, and this is kilogram here. So the kilograms cancel each other out. So the boat, so jumping in the boat only slowing down a little bit. Alright, we good? A 1,000 kilogram car is moving at 2.2, the 2,200 pound car is moving at 5 meters per second to the right. Let's make this a 100 kilogram person is running at 20 meters per second to the left and runs into the car. They stick together. This is important because we combine their masses together and move in a direction. So do you think the person is going to push the car, or is the car going to push the person? So let's look at the before. By the way, I'm going to let positive, so positive be to the right, and negative be to the left. It's very important that we sign a plus and minus for the directions because, again, these are velocities. So we have a car, 1,000 kilograms, moving to the right at 5 meters per second. And we have a person moving to the left at 20 meters per second. Yeah, 220. So afterwards, they're going to stick together. And this is where I would guess that they're fine. Always just guess that they're going to go to the right. If you get a velocity that's negative, it means they're going to the left. So just go ahead and guess that they're going to the right. We're going to guess that the car pushes the person. Later on, if we're wrong and we get a velocity that's negative, that means they're moving to the left. Well, if I change this to 1 meter per second, it would be the opposite. That's just how the math works. So it's like a very slow moving car that the person was able to push. So, total momentum. So it would be 1,000 kilograms times 5 meters per second. So this would be positive 5 meters per second because it's to the right. So plus 100 kilograms times negative 20 meters per second. We put negative because it's going to the left. We have to include direction on our velocity. I said it's equal to a constant. No. In this case, it's 3,000. If you quit talking and pay attention, in the previous example, we're on a different example. Last time I said the start was equal to 0, and so afterward it'll stay 0. Now I'm saying it's at 3,000, and so it will stay 3,000. So we know the total momentum has to stay constant. It has to stay at 3,000. Note this number is positive, so it's going to the right. The car does push the person. So this 1,000 times 5 is 5,000 kilogram meter per second. 100 times negative 20 is negative 2,000 kilogram meter per second. 5,000 minus 2,000 is equal to 3,000. So now we can do the right side. The total momentum on the right side be equal to the total mass. 1,000 kilograms plus 100 kilograms times whatever the velocity is. And that would equal 1,100 kilograms times whatever your velocity is. So we know that the momentum before has to equal the momentum after. So that would be 3,000 is equal to 1,100 times velocity. Again, instead of doing algebra, you can use the triangle. So we know that 3,000 is equal to 1,100 times velocity. So velocity has to be equal to 3,000 divided by or over was 3,000 over 1,100. And that would equal 2.7272, and the 72 is repeating. And the units for speed or velocity is meters per second. And this number is positive. So since it's positive, it means the car and person will move at 2.7272 meters per second to the right. Because velocity includes the direction. The car was moving and the person was moving. They were running toward each other. So the car slows down from 5 meters per second to 2.72 meters per second. The person changes its speed by how much? Yeah, so the person's now moving at 2.72 meters per second to the right. So they're going from negative 20 meters per second to 2.72 carried meters per second. So what's the total change? Yes. The total change would be equal to 22.72 meters per second. You take final and initial and you subtract them. So final minus initial would be equal to 2.72 carried meters per second minus a negative 20 meters per second. And this minus and minus makes an addition, so 2.72 meters per second. All right. An object of unknown mass is traveling at 20 meters per second and hits a stationary object and traveling at 20 meters per second to the right. Have to include a direction. So momentum, really importantly, it requires velocity, not speed. Because the direction of the object plays a very important role in momentum. Momentum also has a direction, by the way. So when you have a momentum to the right, momentum to the left. They have to match on both sides. So after they collide, the total momentum is 500 kilogram meter per second to the right. So we have an object with a mass of m traveling at a speed of 20 meters per second, and it hits an object whose mass we don't know, but its velocity is 0. So I'll go ahead and put 0 in here. This is or before or after. So we have m times m plus some mass we don't know, and they're going at some speed we don't know. What we do know is the total momentum afterwards. So the total momentum afterwards is 500 kilogram times meters per second. So we have a lot of stuff we have no clue about. But we know how to solve this problem because the total momentum afterwards has to equal the total momentum before. So the total momentum before would be equal to the mass times 20 meters per second plus wherever the question mark, the mass of this object, times 0. 0 times whatever this is 0. So we can remove that. So the mass, so the momentum on this side would be equal to the mass times 20 meters per second, and it has to equal 500 kilograms. So mass times 20 meters per second has to equal 500 kilogram meter per second. You can leave off units if you like working without units. We know that mass is going to be in kilograms anyway. So we have mass times 20 is equal to 500. So mass times 20 has to be equal to 500. We're solving for mass. So mass would have to be equal to 500. 500 is over the 20. So that's 500 divided by 20. So that's equal to 25, and it'd be kilograms. So the object had to have a mass of 25 kilograms for this to happen. So when doing momentum examples or equations, what you need to do is draw a before and after image. Calculate the total momentum on one side, calculate the total momentum on the other. This will give you, we know that the momentum before is equal to the momentum after. So we can make an equation. If we have an equation containing three things, so two numbers and another, we can use a triangle to get the equation for the variable. At this point, everyone should know how to use the triangle. So if we have something multiplied together, m times 20, this is m times 20. They're next to each other. Yes? Makes sense? Alright, we're out of time. The code word of the day is this. The code word is on your screen. So any questions? I think so too. Note that on your homework and stuff, you need to be doing all this, showing your work, as it's very easy to make a mistake if you just plug in numbers. I wrote on the top of the page, I believe, for credit, you must show work. Depending on whether or not I take half the points off or all of them. It just depends on the mood of the day. I think on this homework I took 2 points out of 5. that's it for the day.